Bala Sardinska. This is Lab 1, Constant Velocity for Physics 1. So, introduction, purpose, and model. So our lab layout was to capture a video of an object moving at constant velocity. We pushed a circular tape along a meter stick in a straight path. Then we took our video that we recorded, we put it into Tracker, found the data of position versus time to graph the actual velocity from Tracker, and we did this by tracking the point mass, and then we put the data from Tracker into GlowScript to find the predicted velocity and data of the ball moving at a constant velocity, and then we compared the predicted data versus the actual data. So predicted data was the GlowScript, actual data was the Tracker, and we compared it I compared it via Excel, and this demonstrates Newton's second law, which I'll get into more in a second. So this is a screenshot of the video that we showed, put into Tracker. Here we have our circular tape, and there it kind of shows the point mass that we tracked. A negative velocity is shown here because the tape is moving in the negative x direction to the left. Our system is the tape, and our surroundings here would be the table. So the physics principles we used here were F net equals 0 because the forces are acting on it, they sum to be 0, because F net is change in velocity times mass over delta t, and the change in velocity is 0 because it's moving at a constant velocity, which means the final velocity right here equals the initial velocity. And this formula we can also apply because the F net is 0. This goes away to show that the final velocity equals the initial velocity, and again, net force is 0. So this is the code that we used to find the predicted model. It's right here, but this is the important part of it. The position starting is 0. The velocity, that's the velocity, the constant velocity, and we found it using final position minus initial position divided by delta t right here. Our initial starting time was 0.6 seconds because that's when our motion started, and then our final time was 3.32 seconds because that's the final time stamp of the clip that has motion. Our delta t is 0.017 because that's the delta t we used in Tracker, so each of the little clips were 0.01 seconds apart. And then our F net is just 0 because a constant velocity means 0 net force, as previously discussed, which also reflects Newton's second law of motion. And then our updated ball position, which we have shown right over here, is ball position plus the ball velocity, which we calculated here, times delta t, which we already went over. And then this is a video of the GlowScript running, so this is what our code looks like. It's a short little video. Anyways. Okay, results and error. So our GlowScript line, which is right here, once we plotted it as we showed before, we took the data from there and we put it into Excel and along with the data from the Tracker. As you can see, the Tracker data is almost perfectly linear. There's just some user error there that I'll get into in a second. And the GlowScript data is perfectly linear because it is made by a computer. And the GlowScript data is perfect because it doesn't account for friction forces, like forces of friction and air resistance that is happening in the actual data from the Tracker. So, and then another thing is Tracker is old, so it's not going to be perfect as shown here by another curve. So some what ifs is, well, what if we fix the code to account for friction and air resistance? It would probably be more linear. What if, same thing, well, what if there was no external forces? Then our Tracker data would probably be more linear. Questions, but her what if question, from the instructor, was what if we flipped the x-axis? All I would do is just change the direction of the velocity from going in a negative direction to a positive direction. And then what if can we account for the other F net forces? No, because we don't really know what they are. So yeah, we have the forces that we do and can't account for friction and air resistance. Okay, thank you so much. I hope you enjoyed the last 5 minutes of me talking about tape.